identify, maybe we'll give an example of both. Okay, so for a parabola, we would have, how should I do this? All right. So for the parabola, we have only one variable is squared. That's the defining characteristic for the equation of a parabola. Okay? If both variables are squared, you know it is not a parabola. For a hyperbola, and I'll put this in standard form, we could have a 4x squared minus 16y squared plus ... So for the hyperbola, we could say one squared term is negative. So when you look at the equation of an ellipse and the equation of a hyperbola, the equation for the hyperbola is going to have one of the terms subtracted, or one of the squared terms subtracted. An ellipse will have something like this: 8x squared plus 32y squared plus ... So these are different coefficients, but both positive. Okay. Using a similar description, what would we say about a circle?
Same coefficients are both positive.
Same coefficients, both positive. Great. So for circle, we could change this. We have a 4x squared, and this would not be a minus 16, it would be a plus 4y squared. So if those coefficients are the same and both positive, we know it will be a circle. I wrote those all out. Graph going to be?
Parabola.
Great. It's going to be a parabola because the x variable is not being squared. So we know it's going to be a parabola, first of all. For the parabola, what I recommend is determining, does it open up or down or to the left or to the right first. So let's see, for the parabola, if you, I'll write this in, you could have a y equals positive x squared, you can have a y equals negative x squared, you can have an x equals positive y squared, and you can have an x equals negative y squared. So what you're thinking is up, down, left, or right, which fits with which? Haley?
The first one's up.
This is up. Good. So this is the first, in Algebra 1, these are the first parabolas you learned about. That points upward, and if there were a negative in front, that points downward. All right, and so Algebra 2, we take the inverse, we switch x and y, and if it's positive, it's going to point to the right. And if it's negative, this is going to point to the left. Okay. So you identify that it's a parabola. Have in mind, write it down. Does it point up, down, right, left? Bless you. And then we're going to get the vertex, and then we're going to find P, and then we're going to draw the directrix, and then we're going to draw the parabola. Okay, so you got that information? So I'm going to erase soon. Okay, this and this is where we will find the vertex of the parabola. And so our vertex is going to be 3, -1. And the coefficient, the -1/16, gives us p. So this right here is always equal to 1/4p. And p is the distance from the vertex to the focal point and the distance from the vertex to the directrix. So we found our vertex. We know that p equals 4. Now, those of you that have a different teacher, your teacher may have described, in this case, p equals -4, in which case you would know that it points to the left. Does that sound familiar? Okay, so either way, if you're using the fact that p is -4 and that way you know it points to the left, or if you're using the fact that this is the general form of our equation, so we know it points to the left, both will work out. Okay, I describe it as p is 4 because it's a distance. Okay. So given this, and given this, and given this, we can now graph. We're using the fact the parabola points to the left, the vertex is at 3, -1, and p is 4. Okay, so we'll write that information over here. It's a parabola, it points to the left, vertex is 3, -1, and p is 4. Our vertex is 3, -1. Put a little b by that. P is 4, so that's how far we go from the vertex to the focus. And I know that the focal point is going to be this way, 1, 2, 3, 4, because the focal point is always inside the parabola. So because I know that the parabola points to the left, and it's going to be something like this. We're going to get more specific with that. But because I know the parabola points to the left, I know the focus is over here because it's always inside the parabola. The directrix is the other direction, 1, 2, 3, 4. And that will be, in this case, a vertical line, like so. What's the relationship between the focus, the directrix, and the definition of what a parabola actually is? Jonathan?
It's equidistant to each point on the parabola.
Not bad. So this drawing is not the best. Well, we'll get more accurate. But equidistant, so any point on the parabola is equidistant from the focus and the directrix. Good. Okay, so before I just draw in that parabola, there's a little more information we can determine. How wide is the parabola and what do we use for that? Caroline?
P.
We're going to use P. All right, and what do I do with P? If I were starting at the focal point.
We go like up and, or, yeah, up and like rise over run and all that.
Okay, I'm going to, not slope, I'm going to go up and I'm going to go down, but how far up do I go to get a point on the graph? Don't guess, Jonathan.
2.
2 what?
2 points up.
2p.
2p.
All right, so 1, 2, 3, 4, that's p, and then another 1, 2, 3, 4, 2p, okay? So this distance here, to determine how wide the parabola actually is, you're going to go from the focal point 2p and 2p. 1, 2, 3, 4, 5, 6, 7, 8. All right, now we have a nice, accurate graph. And 2p and 2p.